Okay, so this is linear graphing, the first questions. So let's see A. Sketch the following graph using the two-intercept method. So of course, let us do it at the site. To use the two-intercept method, we have to use x equal to 0 to find the y. Okay, so question A. Y equal to x plus 3. So let x equal to 0, then we find the y equal to 0 plus 3, so equal to 3. Okay, then we get 0, 3. 0, 3, yeah? So of course you can say y-intercept at 0, 3. This is the first intercept. Now the second intercept is we let y equal to 0, then we find x. So the working will be, imagine we let left hand side equal to 0. Okay, so we have 0 equal to, so let's continue. We have 0 equal to x plus 3, and we solve this equation, then we will get x equal to minus 3. Then we can say the x-intercept at minus 3, 0. Okay, so with the x-intercept and the y-intercept, now we can mark these 2 points on the graph. So this is x, this is y. So the x-intercept minus 3, 0, somewhere here. Minus 3, 0. The y-intercept 0, 3, somewhere here. 0, 3. Then we draw a straight line. Draw a straight line like this. Okay, then we get y equal to x plus 3. This is the straight line. Okay, now let's move on. Question B. Question B. Sketch the following graph using the intercept gradient method. Okay, so our question is y equal to 2x minus 4. Okay, our intercept, our y-intercept, of course, first of all, you have to make sure your equation is of the form y equal to mx plus c. Yeah. So let's continue. We have to make sure our equation is of the form y equal to mx plus c. Yeah. So if it's of this form, then you can look at the number at the back, which is minus 4. This minus 4 is the y-intercept. Yeah, the y-intercept, yes. So which means it is, the y-intercept is minus 4, and then the gradient is 2. So the gradient, yeah. Uh-huh. Uh-huh. Ah, yes. So it means it's going up like that. Yeah. Yeah. Ah, yes. But it won't have any, I mean the gradient of 2, right? Doesn't mean that they will cut the x-axis at 2 or cut the y-axis at 2. It doesn't mean that actually. It just, yeah. Ah, yes, true. Okay, so which means now when we sketch the graph, y, x. So first we, okay, yeah, sure. Okay, so what we do is we mark the y-intercept on the graph, -4, and then when the gradient is 2, which is a positive number, we just draw a straight line going up, and that's all, yeah, just like that. You may label it y equal to 2x minus 4. Yes. Okay, so let's look at C then. Sketch the following graph on the same sets of axes. Use either method. You may need to rearrange the equations first. Okay, so they give us y equal to 3x minus 1. Okay, so let's handle this. Y equal to 3x minus 1. So at the meantime, they give us x plus y equal to 3. Okay, so let's say we use intercept method over here. Intercept method. So that means we let x equal to 0. We find y equal to 3, 0, minus 1 equal to minus 1, and we can say that y-intercept at 0, minus 1. So I'm using the intercept method, the intercept method. Now I let y equal to 0. Then imagine I substitute 0 over here. Substitute 0 here. So I will get 0 equal to 3x minus 1. Then I have to find out the values of x. I have to bring minus 1 to the left, so that I get 1 equal to 3x. Then I have to bring 3 to the left. So what happened here is they are multiplying. 3 multiplied with x here. So you bring the 3 over, you divide. So in that case, we get 1 over 3 equal to x. So we get the x now. Then we can say that x-intercept at 1 over 3, 0. Okay, so this is the informations that we obtain for the first graph. Okay, for the first graph, let's say I just draw out the first graph. So we have x, y, 0, minus 1, somewhere here. 1 over 3, 0 will be somewhere here. 1 over 3, 0. Okay, then we draw a straight line. Okay, so this straight line is y equal to 3x minus 1. So now let's do the same thing for the other equation. So let's say I do it down here. X plus y equal to 3. So I'm using intercept method again. So where I let x equal to 0. So imagine I put 0 here. Then I get y equal to 3. Okay, so y equal to 3. So this is my y-intercept. So y-intercept at 0, 3. Now I let y equal to 0. and that's y equal to 0. I put 0 here. Then I get x equal to 3. So my x-intercept at 3, 0. Okay. Now I have to mark it down. 0, 3. Somewhere around here. 0, 3. And then 3, 0. Somewhere around here. 3, 0. Okay. Then we draw with a straight line. Okay. Then this is x plus y equal to 3. So that is how we do it. We put the two straight line on the same axis. So it look like that. They intersect. Okay, so this question settled. Now let's move on. This is question C. Question D. Find the point of intersection in the above sketch. This is question D. So meaning that we want to find the intersection point. We want to find these intersection points. So in order to find this intersection point, we have to use simultaneous equation. Okay, so I put it here, D, simultaneous equation, where we do like this. Y equal to 3x minus 1. And we have x plus y equal to 3. So equation 1, equation 2. Now, let's say I'm using substitution method. So I'm going to substitute 1 into 2. So how I substitute is, my y is 3x minus 1. I will substitute into the y here. Okay. So after substitute, it will look like this. X plus, so of course you have to look at equation 2. X plus, the y is replaced by 3x minus 1. Then the whole thing is equal to 3. And then we have 4x equal to, okay, imagine x plus 3x is 4x. And then the minus 1, I shift to the right. 3 plus 1, I get 4. Then I want to find x. Imagine 4 is now multiplying with x. So the opposite of multiply is divide. So when you shift 4 over, it will become divide. 4 divided by 4, and you get 1. So you get 1. And this is the x coordinates of the intersection point. And we want to find out the y coordinate as well. So I put it into equation 1. I substitute x equal to 1 into equation 1. So I get y equal to 3, 1 minus 1. As you can see, I'm using x equal to 1 here. Substitute into the x part. Then I count. I will get 3 minus 1, which is 2. And my intersection point, is 1, 2. Okay, 1, 2. So meaning that this point has coordinates of 1, 2. Okay, so 1, 2. Yeah. So basically, this is how we solve C and D. Okay. So settled already. We look at part E. Part E, let's see the question. Determine the gradient of the following straight line. So that gives us y-intercept 6. That gives us x-intercept minus 3. Okay, so what we need to do is we need to find the gradient. So there is a formula for gradient where it is gradient equal to y2 minus y1 over x2 minus x1. So this is the formula to find gradient. Beside this formula, we have another formula to find gradient. So gradient equal to negative y-intercept divided by x-intercept. So this is the other formula to find gradient. So for practice purpose, let us use both method. Then from here you decide which method you prefer to. Okay. So let's say if you want to use the first formula here, or maybe I should start with the second formula first. The second formula is more direct for our case here. 6 is actually the y-intercept as it stays at the y-axis. Okay, so I write it down. Gradient equal to negative. So the negative is part of the formula. It is there originally. Okay, it is there at the beginning of the formula. So y-intercept is 6. We substitute 6 on top. The x-intercept, you can look at the graph. You look at this point. This is the x-intercept. X-intercept is minus 3. So we substitute minus 3 at the bottom. And we count it. So imagine 6 divided by minus 3. You get minus 2. Minus 2 with another minus. So it ends up with positive 2. So this is actually positive 2. So this is the first way to find the gradient. If you are not using this way, then the other way is you can use formula like this. So where we take this point 6 as 0, 6. The coordinate is 0, 6. X is equal to 0, y is 6. Whereas for the other point, this point, x is minus 3, y is 0. So minus 3, 0. Okay. So then we find out the gradient then. Find out the gradient. Gradient equal to y2 minus y1. So imagine 6 minus 0. 6 minus 0. Or okay, maybe I set up like this. Okay, maybe I set up first before I substitute. Okay, let's say I set up in this way. This is x1, y1. This is x2, y2. Okay, I set up like this, and then I just minus accordingly. So based on the formula, we use y2 minus y1. So that means 0 minus 6. 0 minus 6. At the bottom, we have x2 minus x1, so which is minus 3 minus 0. Minus 3 minus 0. Then we go and count the gradient here. We will end up with minus 6 over minus 3. And you count it, you will get 2. So it means no matter which method you are using, this formula or this formula, at the end, the gradient is the same value, which is 2 over here. So this is question E. And then the next one is question F. Find the gradient of the line that passes through the points 1 minus 3 and 5, 2. Okay, so let's say I call this F. Okay, so for F, you want to find the gradient. So basically, you can just use this formula. Using this is not suitable because we don't know the y-intercept. Y-intercept is of the form, you know, 0 something. So that is y-intercept. We don't have that y-intercept here. We don't have 0 something. So we don't use this formula because we don't know the y-intercept. We also don't know the x-intercept. X-intercept is of the form of something 0. We don't have that also, you know, we don't have something 0. So we don't know the y-intercept and the x-intercept. Using this formula is hence not suitable. So we stick to this formula where we call this point x1, y1, x2, y2, and we just apply the formula accordingly. So gradient equal to y2 minus y1 over x2 minus x1. So we count the gradient, we will get 5 over 4. This is the gradient. So of course you can put it as 1.25 if you want. So that will be same also. So we have settled this page.